Hello and welcome you all in the course of Probability and Statistics. Now, I am your instructor Hardik Joshi. Now, in this lecture, we should learn about, say, normal distribution. So, let's start normal distribution. So, first of all, we have to just give the what is the difference between the previous two distribution, that is, say, namely binomial distribution and Poisson distribution. So, what is the difference between previous two and this normal distribution? So, the binomial and Poisson distribution are the definitely most useful theoretical distribution, and now that corresponding to the discrete random variable x. Whereas this Poisson, this normal distribution, that is, in order to have mathematical distribution suitable for dealing with, say, quantity whose magnitude is vary continuously, say like weight, height of the individual person, at that time the discrete random variable is not suitable, because the height, say weight of any of the particular person, in general we have to say that any of the random experiment, if we have to measure, say, light of a bulb in a particular, say, minute, hour, week, year, so at that time the discrete random variable is not suitable, that is, we have to use the continuous random variable. And now if we have to go through the continuous random variable, then the previously two, that is binomial as well as Poisson distribution, is not suitable. That's why we have to go, or we have to use this normal distribution. So finally we have to conclude that binomial and Poisson distribution is corresponding to discrete random variable, whereas this normal distribution is corresponding to continuous random variable. Now the same thing we have to reflect in the last line. So normal distribution is one of the most widely used continuous distribution. Say normal distribution is first introduced by de Moivre in 1733 in the development of probability and statistics. Now, say after some year, that is later on, say one of the famous mathematicians, Laplace and Gauss, were also modify or give them contribution in the normal distribution to develop or changing in some of the strategy. So they have to modify the distribution which is first introduced by de Moivre. That's why this distribution, that is normal distribution, is sometimes also referred as, say, Gauss distribution, because Gauss has modified it. So the formula for calculating the exact probability of the normal distribution, Gaussian distribution, is known as the probability density function, that is PDF. So the formula for PDF corresponding to this Gaussian distribution is given by this mathematical expression. So f of x mu sigma is exactly equivalent to 1 upon sigma into square root of 2 pi into e raised to minus x minus mu whole square upon 2 into sigma square, where this x, mu and sigma are the Gaussian or normal distribution parameter. We have to talk precisely about what is x. So x is the random variable. That means you have to find out the probability of which particular random experiment, that is represented by x. Say mu is the well-known mathematical expectation, that is mean. The last one, sigma, that is standard deviation. So whenever we have to deal with the mathematical formulation, so at that time these are the main consult, that is corresponding formula to exactly evaluate the probability of that particular random variable. So let's start normal distribution is graphically represented as follow. Now these are the standard shape. Remember, listen carefully, these are the standard shape of this normal distribution, that is Gaussian distribution, and is also referred as a normal curve. Now as you seen that at the middle we have to write down the mu. Now that is the mean and is also known as the highest point of the curve, downward the curve, and the remaining parts we have to write down by this color, that is pink color, that is known as the upward curve, because at that point the distribution, say just like take the frequency peak value, that's why is known as the upward curve, and that particular where the green and the pink line meets at the precisely a particular point, say mu minus sigma, and in right hand side mu plus sigma, that point is known as a inflection point. Why is known as the inflection point? Because at that, say in the between mu minus sigma and mu plus sigma, the curve just like take the shape concave, but after that point suddenly, that is drastically, the distribution is decrease and gradually attains its steady state level. That's why is known as the inflector point. So normal distribution is a limiting case of the binomial distribution under the given condition. The first one, say n, the number of trial is infinitesimal large, that is n is approaches to infinite. So these are the first difference between this binomial and this normal distribution. In this distribution, the value of n, that is whatever random experiment you have to repeat it, it's repeated in very high manner, that is number is very large. The second condition is the neither p or q is very small, that is probability of getting a success or getting failure in one individual trial is not very small. Now let's see some of the property, that is characteristics of this normal probability distribution. So the normal probability curve, now with mean mu and the standard deviation sigma, has satisfied the following property. Now these are the standard shape of this normal distribution, and mu middle line is known as the highest, that is highest point is achieved by the distribution at that particular point, say mu, and the mu minus sigma, that is left hand side, and the right hand side mu plus sigma is known as inflection point, because at that point the curve is gradually decrease on both negative as well as positive x-axis. Now the first property, the curve is bell shape, so it is obviously seen from the figure. Now the shape of this normal distribution is just like a bell, that's why it is known as the bell shape. And now also we have to say that is symmetric about the line x equal to mu. If we have to just assume say middle line just like say mu, if we have to assume is equivalent to 0, then on that right hand side as well as left hand side, both the distribution of this curve is symmetric. Now the second and main important property for this normal distribution, the mean, median and mode of the distribution are coincides and is equivalent to exact when the value of function is at mu, that is at the middle of the point, because definitely mean, that is just like the middle value. So the distribution is symmetric, so middle value is at the point just like say f of mu. Median is also same, and mode, the highest frequency, that is the curve has achieved the peak point definitely at the point mu. That's why the mathematical expectation mean, median and mode are coincides. The third property, x-axis is an asymptote to the curve. Now you have to see in the curve, this normal distribution now is suddenly decrease and achieve, or we feel like that is very nearest to x-axis, but it's a characteristics, this curve is very nearest to x-axis, but is never cross the x-axis as in the both direction, positive x direction and negative x direction. That's why x-axis is an asymptote to the curve. Yeah, we have to say that tail of the curve, because in both the directions is just like a tail. So tail of the curve never touches the horizontal, that is x-axis. Now, the fourth property, no portion of the curve lies below the x-axis. As we have to see in the distribution, that is graphical representation, the curve lies just on above the x-axis, because the probability function can never be negative. Now, the point of inflection of the curve are the point x is equal to mu minus sigma and mu plus sigma. This already we have to discuss. At that particular two points, suddenly the distribution achieve its steady state level. Yeah, suddenly it decreases. That's why it is known as the inflection point. The total area under the normal curve is equal to unity. Now, the graphical representation, that is the area under this curve, is definitely is equal to 1, because we know that the highest probability of any of the random experiment, that is sample space, is 1. So area under the normal curve is equal to unity, and the percentage distribution of area under the normal curve is given below. Now we have to discuss the first option. Say about 68.27% of the area is fall between the mu minus sigma and mu plus sigma. That is the middle point is mu, and just we have to move on the right hand side as well as left hand side, then we have to get the point mu minus sigma and mu plus sigma. That is the dotted line, first dotted line. So we have to say that the probability of continuous random variable x lying between this mu minus sigma and mu plus sigma is equivalent to 68.27%, so approximately 0.68. Similarly, we have to say that the approximate 95.45% area falls between mu minus 2 sigma and mu plus 2 sigma. That is, we have to say that for sake of conveniency, again we have to say consider figure in this slide. So probability of continuous random variable x when is fall between x mu minus 2 sigma and mu plus 2 sigma is approximately equal to 0.95. Similarly, we have to say that the probability of continuous random variable x when is fall between mu minus 3 sigma to mu plus 3 sigma is approximately say 0.99. So is very nearest to 1. So ultimately we have to conclude that the total area covered by this normal distribution is equivalent to 1. So thank you so much for paying your attention.